Hello everyone and welcome back to InSciLab Tech Community. I'm Dr. Ranjana Varma, a research consultant at InSciLab Tech. As part of our For Researchers by Researchers initiative, I'm here to show you how to perform XPS analysis using OriginPro. I have divided XPS analysis into three parts for clarity and accuracy. This is the part 3 of the XPS analysis series. In the first part of the series, we have performed carbon correction and calibrated the survey spectrum. In the second part of the series, carbon correction is used to process the high-resolution titanium total peak of my TiO₂ sample using user-defined baseline method. Now, the oxygen 1s peak is often deconvoluted into 2-3 components such as lattice oxygen, surface oxygen or hydroxyl oxygen depending on the sample. In this video, we will deconvolute the oxygen 1s peak and do the fitting. So go to your origin file where you have saved the data. Now this is my oxygen CSV data. Enlarge it. I'll add 2 new columns in this. I'm doing this to avoid any modification to original data during the analysis. So copy this and paste in the new columns. Copy the sample information also. Now this C column is nothing but the x-axis, so select it and set as x. Now what we have seen that binding energy offset of 1.6 electron volt is observed. This is shown in part 1 of the XPS series video. Link is provided in the video description. So go to the column C, formula box, type C plus 1.6. So your binding energy will be added with 1.6 electron volt. The offset in the binding energy observed. Now we can plot this calibrated binding energy versus intensity by selecting this column and go to the line plot. Now to do the fitting, go to the analysis, peaks on baseline, peak analyzer, open dialog box. Now goal is to fit the peak, select that, go to the next, select the baseline mode as XPS, go to the next. Select the method share layout toggle as per the visually observe the baseline created. So toggle seems to be good. Next. Now this is a crucial step for deconvolution. Let's see how many peaks origin is auto able to find. Click on find. We see that only one peak is detected by the origin software. But for my TiO₂ sample, I am expecting 2 oxygen components, one corresponding to the lattice oxygen and other to the hydroxyl oxygen. But what we have observed that origin only detects 1 peak. So I need to add additional 1 peak in my sample. You may require to add additional 1 or 2 peak as per the observed peak broadening and expected components in your sample. If this additional peak truly exists, the fitting will give it a meaningful area. If not, origin will fit an area close to 0, meaning that added peak does not exist in your sample. So let's do it. Go to your origin. Now uncheck the enable auto find and click on the add. Go to your spectrum and select the position, appropriate position where you feel like your peak may be present and double click on that particular position. Select done, go to the next and finish. So you have the deconvoluted peak with 2 peaks present at 530.1 and 531.2 electron volt positions. Now we'll go to the origin oxygen book and the fitted peak information is added as a new sheet. Peak properties such as area, FWHM, center of the peak is also present as a new sheet. Peak 1, peak 2, residual peak, community peak is presented in another sheet and baseline data is present in new sheet in the same oxygen book. Now we want to plot a deconvoluted oxygen 1sp to be using my paper. So select the two columns, go to the plot, scatter plot. Once plot is done, at the left corner the one number is written. This is for adding the new layers to the spectra. So when you double click it, layer content window will open. In this, all the data which are present in origin project will be shown. Now we want to add the layers corresponding to the data which are present in my oxygen group. So let's go to the oxygen group. I want to add the data for the fit peak one. Select that, click on this arrow. This I will add a peak 1 data in the spectrum. Fit peak 2, select, add to the layer, add a cumulative peak, select and click on the arrow. I want to add the baseline, so check where baseline data is there in the oxygen. This is a baseline data, select and click on the arrow. So all the data correspond to the peak 1, peak 2, cumulative peak and baseline is been added to your spectra. Select OK. All these are in overlap. Now we want to make it presentable font. Double click on the spectra. Plot detail window will open. Now my original data scatter points are in square form. I want in a circular form. So any other form if you want, you can select it. Peak 1, I want to be present as a line form. Width I'll select 5. Color I will use red color. For peak 2, I want plot type as a line. Width as 5 and color as blue. For cumulative or sum peak, I want line plot. Width I'll keep slightly lower and color green. I generally keep some transparency so that if fitted peak and sum peak overlap, then we'll able to see the fitted peak in the background of my sum peak. For the baseline, select the line peak, color gray, width 5. Click OK. So now your plot is beautified. I don't want this information removed. Intensity values are also not presented in the paper. Remove it. Now binding energy for XPS is presented from high to low value. Double click on the x-axis. Go to the scale tab. Type the higher binding energy in the from column. So I want it to 540 and in the 2 lower binding energy value. Say apply. So your binding energy is reverse. I'll usually add lines on the top and right of the plot. So go to the lines and text, go to the top, show lines and text. I don't generally use the major and minor text, so select none, apply, do the same for the right side. Select none for major and minor, apply. Okay. So your plot is ready. Now this spectra correspond to the oxygen. So go to the text toolbox and click inside the plot area. I'll write down the spectra information. This is for oxygen 1s. I'll click here. Go to the text toolbox and write the peak information. So this is my oxygen lattice peak. I want lattice to be in the subscript form. So this is for peak 1. For peak 2, this is the OH radical. You can keep outside or inside as per your interest. Once it is done, go to the file and save your plot for using in the paper. So export graph, open dialog box. File type, select the PNG, write down the file name and select the location where you want to save this file. Always check that DPI is at least 300 resolution. Select OK. So your oxygen PNG file is been created. You can open and check that. So this is your oxygen 1s deconvoluted high resolution XPS peak. This you can use in thesis, research paper or presentation. I hope third part of the XPS series is helpful for your research. To continue the conversation, ask questions or collaborate with fellow scientists, please join our community hub at InSciLab Tech. The link is in the video description. We would also love to hear your feedback directly. Let us know what you think in the comment. Thanks for watching.